In this video, we're going to talk about interfacing with hardware. So we talked about basic operation of Arduino in the previous module. So today we're going to talk about how to use digital I/O pins and analog I/O pins to connect with external device. So when we are interface between Arduino and other devices, we use I/O pins, and normally when we are connected to external devices, we are not only sending out digital input-output signals or analog input-output signals, we also need to build some simple circuits. For instance, if we want to connect to an LED, we must know how an LED needs to be connected. It needs to be connected to another resistor in order to prevent the current is too huge to burn the LED. So there are many other things we might need to pay attention to so that we're not going to burn the external device. So let's talk about if we are using audio outputs. Audio outputs is a very basic device that we use because we want to get user attention so that they will listen to us, to let them know what's going on and what is important. So if you look into your notes, you're going to find out the outlet of the speaker is actually only two wires. One is positive, the other one is negative, and essentially it's just a resistor. So this is a structure that if you provide different kind of if you provide something on and off, it's going to attract the magnet to vibrate a membrane. So when the membrane starts to vibrate, we're going to hear the sounds. So it is actually pretty straightforward. If we change the frequency, we can change the tone. The basic setup of the circuit is pretty straightforward. Typically, a speaker is kind of small, and in order to provide the signal to the speaker, we connect another 200 to 500 ohm variable resistor, so we can tune the volume of the speaker. But when we connect that to an Arduino, we need to connect it to a digital pin, because as I said, analog speaker is actually connected to something that generates frequency. So if you are using analog output, you only change the voltage from 1 volt to 5 volts, that is not going to work. It might be more ideal if we connect that to a digital outputs and we can change the frequency. So in this circuit over here, we are connected one pin to the ground, and the other pin is going to be connected to pin 9, which is a digital output. We also connect another 100 microfarad capacitor that is used to filter out noises. And over here, this is an variable resistor. So if we control that one, we actually control the voltage get into the speaker so that we can change the volume. This is a very typical code for a speaker, and when we are doing this, we use a very specific command tone. You can see it's over here, and this one is actually change the frequency. This one over here is 262 hertz, and this one over here is 1494 hertz. So we are playing the tone for a certain amount of time, 100 millisecond, and after that we will stop for another 100 millisecond. So if you play this one over here, you're going to hear it's actually like the sound of ambulance, and so you can try it and to see whether it works. But keep in mind, you will need to connect a speaker to your Arduino with the circuit we provide in the previous slide. So here is some basic notes you can use, and the unit is going to be hertz. So when you are trying to play music, you can go online and look for the frequencies for corresponding notes. And this is just a basic thing that we use from C4 to C5. So if you learn music, you know what I'm talking about. But if you want to change the tone frequency change your tone, you will need to change your frequency. So those are the very standardized frequency that we use to play music. So those are the table you might want to keep, so that if you want to make some kind of songs or anything using Arduino, this might be the good practice that you can use. The second thing that we are going to use is interface with the chip. So sometimes we are not only use Arduino to connect it with an single device. In many cases, we might use another chip, digital chip or analog chip, so that we can have more functions. For instance, Arduino itself doesn't really do a whole lot of, for instance, TCP/IP. So if you want to expand your Arduino that can be connected to network, you probably don't want to code everything yourself, because there are many things you need to study, and you might not have enough knowledge to do those kind of things. So in that case, we can just purchase a chip that help us to perform those basic tasks. So this one over here is multiplexer. It's a 4051. So the function over here, it had because an Arduino only has 6 analog inputs, and that might not be enough for analog inputs available to your application. So if you want to have more of those kind of things, you might consider to use a multiplexer to increase the input of your analog inputs. So this is a basic connection that we can use. So if we control the ABC pin over here, we can actually control which one get into the Arduino 0 over here. What this means is that we have I think 8 channels from channel 0 to channel 7. So if we change the input pin A, B, and C, which is corresponding to S0 to S2, if we change the switch over here by using 3 digital pins over here, we can actually control which channel from channel 0 to channel 7 actually get into analog 01. So in other words, if we are using those 3 pins over here, we are increase 1 analog input pin into 7 analog input pin. So this one can be very handy, because in many cases we might require to increase the ports, and this chip is definitely do a job for us. So this is the code that we're going to use. So if we specify the digital pins with the corresponding number like 000, 001, 010, those kind of 8 combinations, we can actually select which channel that get into the analog one. So when we are reading the analog inputs, we just do the regular thing, because we just take the analog 0 into our consideration. But by controlling the 3 pins of digital outputs, we can actually expand our analog input from 1 to 8. So this can be a very handy one. This chip is not going to be used only here. You're going to be used in many other places. So this is something you might keep in mind that we can use to interface with our external devices. And those are just 2 examples. You can expand a lot of different kind of things. If you get the specification of the chip you want to use, then you can definitely use those kind of things to expand the functions that Arduino can work with. So in the next video, we're going to talk about analog output.